Hello, I'm Peter. I'm from Salesforce, and I'm going to talk about managing dependencies. So this is an experience from our life in the last 4 years. We started off as a small monorepo, tiny monorepo, and we scaled up a bit. We're definitely not an enormous monorepo now. We're not even large. I would say we're more mid-size. I don't know, scale's always relative. My teammate Simon is going to talk more about what we do in this monorepo. But for this session, I'll just talk about, or really focus on the fact that we have 1,200 Java dependencies, about 400 packages, and we have a small build team that helps centrally manage our dependencies. So our dependency governance is centralized in a small team. And our goal is we want quality and security out of our build, of course. But we also need to balance this governance with cost controls. We want to automate as much as we can. And so I'm going to start off explaining kind of the basic dependency governance. I think most people are implementing this in their monorepos. The first thing we started with day one was single version policy. You don't have to do this in Bazel, but we decided it was a good idea. And so we implemented it. And so we had a single Maven install rule that we had all of our dependencies in, and that would generate a lock file. And that worked fine until about the point where we got to about 500 dependencies. Then we started having a lot of merge conflicts. So developers were starting to complain to us that, hey, I can't get my PR through because I keep having a conflict in the lock file. And so it was at that point where we had to split our Maven install rule up into, it's about 20 or 30 now, and we have lock files for each of those smaller rules. And then we wrote a tooling layer on top of that in Python that synchronizes versions across all those Maven install rules. So that was a big change for us. So as you're moving from a small to a bigger monorepo, you just have to consider merge conflicts in your implementation of single version policy. The other thing we had to do from day one, we had a lot of concerns from our users about, what if I want my project to stay back on an older version of a dependency, and so we implemented that also. But as it turns out, not many teams have taken advantage of that. We're lucky in that. The second thing with Salesforce is a very security-minded company. We have a lot of customer data. Also, we operate under a lot of regulatory regimes. And so we have to be very aggressive about remediating vulnerabilities, like many of you here. And we're measuring our remediations in the build system in hours. We need to be really fast. And so we have scans running all the time, and so just in terms of scaling, though, when we start off as a small repo with 300 deps, that was pretty easy to do. But as we grew to 1,200 deps, we're getting a lot more just getting a lot more hits from the scanners. And so I would say, as you scale up, just be aware that you're going to be spending a lot of time on vulnerabilities, and you need to remove all the friction from that process because you need to get those through really quickly. And so for us, one of the things we did was early on, we told all our users that you would be able to approve any PR that we do that might affect your service. But we had to backtrack that because as we grew to 50 services, 80 services, we can no longer wait for all those people to approve our PRs. License scans are, when we first started our monorepo, we had just a few hundred dependencies. We managed this in a spreadsheet, just making sure that we had compliant licenses for our company, because our company cares about which open source licenses we use. But of course, over time, that was not scalable. So we have now this is an automated process. Although it's very quiet, we don't spend a lot of time on licenses. We have a PR check to block a PR if it's bringing in something that has a bad license. It's only failed once in 4 years. So it's just a pretty quiet area of our governance. And then we started doing things that we didn't expect. All those three things are pretty common governance checks. And so we expected those, but then we had to start doing things that we didn't expect. And so the first thing was duplicate classes. So when you have a single version policy, you wouldn't expect that in a built product that you would have multiple versions of the same class. That was our assumption going into this, but that assumption was very wrong. And I'll explain just a few examples of these. But we had to implement governance on this. And because we kept seeing all these projects migrating from Maven into Bazel, and they would have more than one copy of the same class in one of the jars. And so most of our microservices that we're deploying are Spring Boot applications. So that's a Java framework. And we happen to be the authors of Rule Spring, which has this rule in it. And so we added the duplicate class enforcement in this rule. So if you use the Spring Boot rule, make sure you turn this on because it's not on by default. But what this feature does is at packaging time, it will detect if there are more than one copy of the same class within the executable jar. And then once we have the detection, then we have to remediate. And there's probably like 10 different reasons why we found this, but I just put a few of them here. One problem that we see are roll-up jars. So open source projects like Netty, they'll release their product as a set of jars, but then they'll also give you a Netty-all jar. And so what we had to end up doing to block these kinds of things is we have a validation rule we have in our build that if it sees anything with the -all on it, it just breaks the build. Synonym jars. So this is another case where some open source projects, they change their group ID in Maven or their artifact ID in Maven over time. And so, but they don't change their Java class path and so, or the package name. And so, so some projects end up with pulling in the old one and the new one, which doesn't violate single version policy because they're different names. And so, so we had to implement additional logic here. So in the Spring Boot rule again, we have a way to pick a winner if you have this situation. But also Maven install has some features too that can help you with this. And finally, within Salesforce, we have a problem we didn't expect, which is developers like to pick a few classes out of an open source jar and just slam it into a jar they're building internally, which then, of course, over time, the copy of those classes become out of date, and then they cause this duplicate problem. So again, there's not a whole lot we can do here. Sometimes we actually crack those jars open, pull those unshaded classes out, package it back up, and put it in our build. But then the real solution to that is we have to just yell at the upstream maker of that. And so that was a real surprise for us. It was very common to have these duplicate class problems. And so as you're implementing your governance, you should consider checking your final packaged artifact to see if there's anything duplicated in there, because that's a good place to do it. And I'll cover probably just one more. So we felt we were pretty good about staying up to date on all of our dependencies. And when we only had like 300 or 400 dependencies, we had pretty good intuition, like, okay, yeah, we're staying up to date on all these open source packages that we use. But as we grew, we kind of lost track of where we stood on things. But we felt we were pretty good because we were patching vulnerabilities really fast. We were staying up to date on all the main frameworks we used. But we decided to implement an old dependency tool to go check, just to do a reporting on what the situation was. And this was a big shock to us. When we first ran the tool, we expected to have some issues with old jars. But in fact, it was, I don't know if it's a disaster, but it was really bad. So we had only 30% of our jars up to date on the latest version of the open source project. So over 70% of our jars were falling behind on the relative to the open source project. And the big bummer about that was 206 were major versions behind. In addition, this tool also just looks at the age, like calendar age of these deps, and we're seeing stuff that's 4 years old, 6 years old, 8 years old, 10 years old. And so I guess the moral to the story is, if you're scaling out a monorepo, make sure you have some kind of reporting tool or reporting capability that you can see how far you're lagging behind the latest of all these open source dependencies. And that's all the time I have. Thank you.